Welcome to the Explainer! Today, we're going to get our hands dirty and build a Retrieval-Augmented Generation system, a RAG system, from the ground up. We'll see exactly how it solves one of the biggest problems with AI today, its inability to access real-time information.
Okay, so here's the game plan. We're going to start with the why, the big problem RAG is meant to solve. Then, we'll actually build a RAG system piece by piece, trace a query's journey right through it, and finally, we'll talk about why this technology is such a game changer.
All right, first things first. We need to talk about a pretty major flaw, a limitation that even the most powerful large language models have.
So, picture this. You ask a standard LLM a question. Maybe it's about something super specific, something that just happened, or even something from your company's private files. Like, what is Decicoder? So the model has no clue, right? But instead of saying, I don't know, it just makes something up. And the crazy part is it sounds totally plausible. It's super confident, but it's completely wrong. This is exactly what we call hallucination. The AI is just filling in the blanks because it has a knowledge gap. So what's the deal here? Why does this even happen? Well, a standard LLM's knowledge is basically frozen in time. It only knows what it was taught way back when it was being trained. That means no breaking news, no access to your company's latest report, nothing that was created after its knowledge cutoff date. It's a closed book. Okay, so how do we fix this? How do we get around this whole frozen in time problem? Well, the answer is this really clever framework called Retrieval-Augmented Generation. RAG completely flips the script on how an LLM works. Think about it like this. A regular LLM is like a student taking a closed book exam. It can only use what it's memorized. RAG, on the other hand, turns that LLM into an open book expert. It gets to look up the facts from an external library right before it answers. And this quote here really hits the nail on the head. You can think of a RAG system as having two parts. First, you've got this super fast librarian who goes and finds the exact right documents. Then, you have a skilled writer, that's our LLM, who uses only those documents to craft the perfect answer. So before our RAG system can start answering questions, we obviously need to give it that library to pull from, right? This is a one-time setup job we call indexing. It's all about preparing our knowledge source. Now, this indexing process, it's a pipeline with a few crucial steps. We start by loading up our documents. Then comes the important stuff. First, we split them into smaller, more manageable chunks. After that, we embed each of those chunks, which is a fancy way of saying we turn its meaning into a string of numbers, a vector. And finally, we store all these vectors in a specialized database, all ready to be searched. Okay, let's make this real with a little bit of code. So if you're using a popular framework like LangChain, the very first step is just loading your data. Could be a PDF, a website, whatever. This line of code here, it's literally just telling the system, hey, this is the PDF I want you to learn from. Right, so after we've split our document into all those little pieces, we get to the really cool part, the magic, really, embeddings. We pick an embedding model, like this one from OpenAI, and what it does is it reads a chunk of text and translates its meaning into a list of numbers, a vector. And the genius of it is that similar ideas get converted into similar sets of numbers. That's how the computer can actually understand the meaning. And for the final step of setup, we take all of those numerical vectors and we dump them into a vector database, something like ChromaDB. Now, this kind of database is purpose-built for one job and one job only. Finding vectors that are mathematically similar to a query vector and doing it lightning fast. And just like that, our knowledge base is indexed and ready to go. Okay, so the library is built, the prep work is done. Now for the fun part. Let's follow along and see exactly what happens in real time when a user actually asks a question. This right here, this is the live pipeline in action. The moment a question comes in, a three-step dance begins. First, the system retrieves the most relevant chunks of data from that knowledge base we just built. Second, it augments the user's original question by tacking on this new context. And then, and only then, does it go to the LLM and ask it to generate an answer based on all that fresh information. Now, this second step, creating what's called the augmented prompt, this is the real secret sauce of RAG. The system doesn't just blindly pass the user's question to the AI. No, it constructs a brand new, super detailed prompt that basically says, hey, LLM, using only the following facts that I just found for you, please answer this question. So this whole package, the context and the original question, gets bundled up and sent over to the LLM. Now armed with all this super relevant, just-in-time information, the model doesn't have to guess or rely on its old, dusty memory. It has the facts laid out right in front of it. And what you get, well, the difference is just night and day. We completely avoid that made-up, hallucinated answer we saw at the beginning. Instead, we get the real, correct information about Dikita Coder. It's accurate, it's detailed, precisely because it's grounded in the source material we gave it, not some old memory.
Okay, so we've been deep in the technical weeds, but why does any of this matter? Let's zoom out for a second and look at just how huge the impact of this RAG approach really is.
I mean, the benefits here are just massive. For one, it slashes hallucinations because answers are based on actual retrieved facts. The knowledge base is always up to date. You just add a new document and boom, it's in there. It also builds trust because the AI can actually cite its sources. And it's way more cost-effective than constantly having to retrain a gigantic language model from scratch.
Now, building one of these systems isn't about finding a single magic tool. It's really about putting together a stack of specialized tools that all work in concert. So developers will use frameworks like LangChain to act as the glue connecting everything. They'll use vector databases like Pinecone or Chroma to store all that knowledge. And of course, they plug in powerful embedding and generation models from places like OpenAI or Anthropic to do the heavy lifting with the language itself.
But this also brings up a really important question. How do you know if your RAG system is any good? I mean, how do you measure success? It turns out it's not just about how good the final answer sounds. The quality of that very first retrieval step is absolutely critical. We measure its precision, which basically asks, is the stuff it found actually relevant? And we measure its recall, which asks, did it find all the relevant stuff? Getting that balance right is what really separates a decent RAG system from a truly great one.
And all of this leads us to a final, much bigger thought. You see, RAG isn't just a clever trick to make better chatbots. By giving us a reliable way to ask questions to massive amounts of data and get back verified, context-aware, and sourced answers, it might just fundamentally change our entire relationship with how we find and interact with information itself.